All right, question 12, there's two ways to do this. Number one, by distance on number line. And number two, algebraically. So I'm going to work through both. Distance from the number line. If we have the absolute value of 2x plus 1 is less than 3, then, well, when I do these, I want it to just be x, so I'm going to halve everything. Like literally everything. So I've got the absolute value of x plus a half is less than 3 on 2. And now this is the same as the absolute value of x take negative a half less than 3 on 2, which means if I have a number line and I start off at negative a half, then I want to go 3 on 2 to the right and 3 on 2 to the left. So negative a half plus 3 on 2 is 1. And negative a half take 3 on 2 is negative 2. So that means that negative 2 is less than x, which is less than 1. So I want all the numbers between these two, yeah? Algebraically, to me, this is the one that makes more sense. So the absolute value of 2x plus 1 is less than 3. So I can say positive 2x plus 1 is less than 3, and negative 2x plus 1 is less than 3. So on the left, I've got 2x plus 1 is less than 3, which means 2x is less than 2, which means x is less than 1. Here I've got negative 2x take 2 is less than 3, so negative 2x is less than, that's going to end up as 3 plus 2 is 5. Yeah, hang on. What have I done wrong? If a half take 3 on 2 is negative 2. So here x is less than, I'm going to change the sign, so x is greater than negative 5 on 2. Obviously something's gone wrong there, so let me double check the work solutions in the book. Question 12. D. Something's happened here. Let me try it again. Negative 2x plus 1 is less than 3. So I've got negative 2x, take 1. Oh, I did take 2 instead, take 1. Less than 3. If you were sitting there screaming at me, I apologise. So negative 2x is less than, plus 1 is 4. So x is greater than negative 2. Which means x is less than 1 and it's greater than negative 2. And we wanted to sketch it on a number line. So here we've got negative 2 and 1. So it's in between these. Okay, let's do E. Again, I'm going to do it these two ways. So this one, I've got the absolute value of 6x take 7 is greater than 5. I'm going to divide everything by 6 because I just want it to be x. So I get the absolute value of x take 7 on 6 is greater than 5 on 6, which means if I have a number line, and here's 5 on 6, I want to go up by 7 on 6, and I end up at 5 on 6 plus 7 on 6, gives me 2, and then I want to go down 7 on 6, Oh, I've done this the wrong way round. This should have been 5 on 6. No, I was right. No, this should have been 7 on 6. So 7 on 6 plus 5 on 6, well, still 2. 7 on 6 take 5 on 6 gives me a third. And I want the distance to be greater than that, so it's this way and it's this way. So it's numbers less than a third and it's numbers more than 2. So x is less than a third and x is greater than 2. Or you can do it algebraically. So we've got the absolute value of 6x take 7 is greater than 5. So that means we've got positive 6x take 7 is greater than 5 and negative 6x take 7 is greater than 5. So here we've got 6x take 7 is greater than 5. So 6x is greater than plus 7 is 12. So x is greater than 2. Here we've got negative 6x plus 7 is greater than 5. So we've got negative 6x is greater than negative 2, which means x is less than negative 2 on negative 6, positive a third. Which means x is less than a third and x is greater than 2. We want to sketch that. So let this be a third and let this be 2. And we're less than a third and we're more than 2. And finally, f. Once every exercise. Hopefully only once. Okay, again, we're going to solve it 2 ways. You don't have to do it 2 ways, obviously. Just pick your favourite. Okay, distance on a number line. So I've got 5x plus 4 greater than or equal to 6. I'm going to divide everything by 5. And I get the absolute value of x plus 4 fifths is greater than or equal to 6 fifths, which means it's the x take negative 4 fifths is greater than or equal to 6 fifths. So if I have a number line and I start off at negative 4 fifths, I'm going to add 6 fifths, so I'm going right 6 fifths, and I'm going to go left 6 fifths, so I'm going to subtract 6 fifths. So negative 4 on 5 plus 6 on 5 gives me 2 on 5. Negative 4 on 5 take 6 on 5 gives me negative 2. And so we're looking at all the numbers greater than or equal to. So we're going this way. So the distance is greater than or equal to 6 on 5. So it's more than or equal to 6 on 5 away from negative 4 fifths. So we get x is less than or equal to negative 2 and x is greater than or equal to 2 fifths. Okay, algebraically, we've got the absolute value of 5x plus 4 is greater than or equal to 6, which means positive 5x plus 4 is greater or equal to 6, and negative 5x plus 4 is greater than or equal to 6. So on the left, so we've got 5x plus 4 greater than or equal to 6, which means 5x is greater than or equal to 2, which means x is greater than or equal to 2 fifths. Excellent. Negative 5x take 4 is greater than or equal to 6. Negative 5x is greater than or equal to 10. So x is less than or equal to negative 2. Let's draw this. So we've got 2 fifths and we've got negative 2. And we want to be more than 2 fifths and we want to be more than or equal to 2 fifths and we want to be less than or equal to negative 2. So let's write that, negative 2 and greater than or equal to 2 fifths. So that's those.